Hello class, welcome back to the Chong channel. Right now we're going to look at two word problems dealing with quadratic equations. Okay, so before we begin, just a quick review on some vocabulary words. So anytime we see the word quadratic, it's referring to something in the format of x squared or variable squared. So anything with a variable squared or an x squared, we call this a quadratic. So these two word problems have to deal with quadratic equations. Okay, so let's look at the first example. The height of a ball, Doreen tossed into the air, can be modeled by the function where x is the time elapsed in seconds and h is a function of x is the height in meters. The number 5 in the function represents. Well, first of all, I did some annotating and this function represents the height of the ball in the air. So I labeled it here. So this is the height of the ball in the air and x is the time elapsed in seconds. So this is the time. Now, let's think back into linear. When we were dealing with linear equations in the past, we had a format y equals mx plus b. Now, b was a constant. Just like over here, this is a constant, a number with no variable. Now, if we thought back in linear terms, this was a constant, but it was also known as the y-intercept, and it was also known as the initial value. Okay, so let's go back to this quadratic situation over here. This is the height of the ball in the air, x is the time elapsed, and this constant 5, what does this represent? This is the initial height. So we actually don't need to go any further and we already answered the question. 5 is the constant or the initial height, and so 5 is the initial height of the ball. However, let's just explain why this is the case. Now, if we are starting, so if 5 is the initial height, then that means time is 0, because that's what we're starting with, time 0. So wherever we see the x, if you plug in 0, when we put all of this in the calculator, we actually get 5. And so this proves why at the time x equals 0, the height is 5, which really means the initial height of the ball. Okay, I hope that was clear enough. Now let's look at another example here. It says, a ball is thrown into the air from the top of a building. The height, h, is a function of t of the ball above the ground. T seconds after it is thrown can be modeled by h is a function of t equals negative 16t squared plus 64t plus 80. How many seconds after being thrown will the ball hit the ground? Well, first of all, we want to find how many seconds. So in this question, seconds is t. So this is what we're finding. These all are supposed to be some sort of t. Okay, but if something hits the ground, what is the height in the air? Well, the height in the air is 0. So this is something that you have to imply on your own. So just a quick review on that alone. When you hit the ground, the ball is at height 0. So whenever you see the height, you're supposed to substitute 0. So the height is 0 and everything else in the formula I copy down. Now, as you remember in the other videos, there's multiple ways to solve quadratic equations. You can do it graphically, by factoring, by completing the square, or quadratic formula. Well, most people prefer quadratic formula because the quadratic formula works in any case. So just a quick review on the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So a is the first coefficient, b is the second coefficient, and c is the constant. Oh, just a quick review from like the question just before it. If this was a totally different problem and they asked us what the initial height was, what do you think it would be? Okay. All right, so now we plug in the formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So I did the math for you. We got negative 64 plus or minus square root. You put all of this in the calculator. We got 9,216. 2 times negative 16 is negative 32. So the square root of 9216 is 96. So I copied the rest, and so just like we did in the other videos, here we have two answers. We have negative 64 plus 96 divided by negative 32, and we have negative 64 minus 96 divided by negative 32. When we simplify the first fraction, we end up with a negative 1, and when we simplify the second fraction, we end up with 5. Just a quick review on what we're trying to solve for. We're trying to solve for seconds. Now, would it make sense to have a negative a number of seconds? No. So anytime you want to solve for seconds and you get a negative number, you have to omit it. Omit means it just doesn't make sense. You got to get rid of it. And so the answer is t equals 5 seconds. That is the time it will take for the ball to hit the ground. And if the ball hits the ground, the height is 0. I hope that helps. Bye-bye.